This video is going to cover some things about C# interfaces and show you some reasons to use them. So to demonstrate why you'd even want to use an interface, I'm going to be building off a previous video where I showed you how you could use inheritance. In this case, I had a parent class of animal, I had children, fish, and dog. I added them to a list. I was able to iterate through and run a couple of common methods. If you didn't see this video, or you're not familiar with how lists work, I'd encourage you to check out my previous video. I'm going to put a link up here in the video now and also in the description. So in that previous video, I was able to use that parent class to make a list of type animals, and then I could iterate through even though they were different. They were fish or dogs. So that's fine, right? We have dogs and fish, both are animals, and then we could work off of type animal. But what if we had, let's say, a pet store, and we wanted to run an inventory and collect a couple of other objects that are completely different than fish or dogs? Let's say we have food for like cats or dogs, and also toys. In this case, it wouldn't make any sense to have food or toy inherit from animal. And you don't want to try and force the animal parent class to have attributes and methods that don't relate to food or toys. So there's a better way of approaching this. And this is one good reason to use an interface. An interface defines the properties and methods, but it doesn't implement in the interface itself. Those are actually included in the classes that are going to implement the interface. And it allows unrelated classes to share functionality or properties. And just a side note, the name typically starts with the capital I. So back to our example, if I have animals and they still are dogs that inherit from animal, fish inherits from animal, I can also make an interface, and it's called iInventory. So it's not a typo here. That's why there are two I's. iInventory. And I can have it have a method that would display the inventory. Now, if I have all of these objects implement iInventory, they also need to have that display inventory method inside of them. So when we have an interface, it's guaranteeing that whatever methods we have in there have to be in the objects that are implementing them. A couple of other things to mention. An interface, like an abstract class, you cannot instantiate an interface. And a class can implement multiple interfaces, and while it can only inherit from one parent class. So you could have many different qualities shared by objects using different interfaces. All right, so let's look at Unity and see what scripts we have. We already have our animal parent class, and we have dog and fish, and we had our control script, which is attached to the script up in the hierarchy. And I've also added two more, food and toy. So looking at those, toy is pretty basic. It just has an attribute of toy name, and I have a default and custom constructor where I can define what the toy name is. And with food, same thing, but this time I have food name and food type, and just the default and custom constructors. I already had my animal parent class, and notice my dog inherits from animal, and my fish inherits from animal. So that's where we were left off. In our control script here, I already had a list, and it was making a list of animals. So let's make our interface. I'm going to go here in Unity and make a new C# script, and I'm calling it iInventory. Inside of here, I'm actually going to get rid of the inheriting from Mana behavior, and I need to change this. Instead of a class, I'm going to say it is an interface. I'm also going to delete this other stuff. Now, this interface is going to be very basic. We don't actually implement or write code in here beyond just defining what is going to be included in the classes that implement it. Here, I'm going to say that all of the classes that implement this will have a method called display inventory. And that's all that's going in this file. So every class that will implement iInventory has to have this method. All right, so to implement this, let's do this on toy first. To implement it, it looks just like inheritance. I do a colon, and then I say the name of the interface I'd like to implement. Now notice it's giving me an error because I didn't implement the method that I defined. So I need to include that. In this case, since it's just inventory, I'm going to have it say the name of the toy. So notice this is the same name as what was in the interface, and it can just say the toy name, for instance. So I'm going to go ahead and save that. Now for food, I can implement it a little differently. So let's also add iInventory up here, but the display inventory method looks a little different. So in this case, I'm going to have it say the food type and then the food name. So now I just need to add that to the fish and dog. Now notice the fish already inherits from animal. You can also implement an interface, and all you do is put a comma in and then the interface name. So for the fish, I have a little longer description when I display the inventory. It's going to say salt or fresh water fish, weighing, and whatever the weight is. And then for the dog, same thing. I do a comma, iInventory. And for this one, the dog is going to say the breed and the weight. So each of these display inventory methods can be implemented a different way for each object. Now back in the control script, before I was just collecting a list of animals. So let's kind of just start over here. I'm going to get rid of what we had. I'm going to have a list, but instead it's going to be of type iInventory. And I will call this inventory. So I'm making a new list of called inventory, and it's of type iInventory because they all implement the inventory interface. So like before, I can add some things to that inventory list. So initially, let's say I added back those fish and dogs into the list. So I've got the name of the list, .add, and in this case, I'm instantiating a new fish. This is the weight and the type, and so on. And then I can also add in the food and the toys. So in this case, I have some canned cat food that is tuna delight, and also, for instance, a tennis ball. So to display my entire inventory, I'm going to use a for each loop. And what I have here is it's going to look at for each item of iInventory type. I is just a shortcut name for the object that's going to be on each time around in inventory, which is my list. And then what I want to do is run the method that they all share, which in this case is display inventory. So I say i.display inventory. So I'm going to go ahead and save this, and we can run it, and hopefully we will see our inventory of fish, dogs, food, and toys. So here we are. We have a freshwater fish weighing 3.4. I suppose I could add pounds after that and things. We've got a Yorkie dog, pug dog. We've got canned cat food, tuna delight flavor, some dog food, a squeaky chew toy, and a tennis ball. So by using an interface, it made it really easy to group all of these different types of objects. And once again, if you didn't see the previous video and you'd like to, I will put the links to those in the description.